Source transformation theorem. Source transformation theorem is used to simplifying the circuit. Independent source only. By transforming the source, the resistor can be simplified by series or parallel. Before, the resistor not in series or parallel. And then the final circuit should consist only one mesh, loop and the element that being asked. This means that, for example, if the circuit consists of 4 loops, you can apply the source transformation to reduce the loops number by 3, 2 until it becomes only one loop. You know how to transform? This is the transformation circuit. Can you see that for the first circuit? This circuit consists of voltage source series with the RS, and then you want to transform to the current source, the circuit number 2, which is the current source is in parallel with the RS. And then you can also transform the current source circuit to the voltage source circuit. What is equation that relates to the source transformation? For example, you want to transform the Vs into Is. Actually, you can use the Ohm's law. Ohm's law stated that V is equal to I R. Therefore, if you have a Vs and then you want to transform to the Is, you just use this Ohm's law by using this value, which is Vs over R. Then you can find the value of Is. And then if you want to transform from the Is to the Vs, use Ohm's law, which is Vs is equal to Is times with Rs. So this is also Rs. Please remember the connection in between Rs with the Vs and Is. For Vs, Vs must be in series with Rs. And then for the Is, it must be in parallel with the Rs. What happens if you series the Is with the Rs? As shown here. By using this circuit, or you can refer to this circuit, if the current source Is is series with the Rs, the Is is flowing through the Rs, which is we want to determine a difference value of Rs for the Is. And then for the Vs, if the Vs is in series with the Rs, it might be the voltage is different. The voltage in Vs is different with the voltage at the Rs. But if you connect the Vs in parallel with the Rs, it seems that you can ignore the Rs because the values of voltage at Vs is same as the values of voltage at Vrs. This is the things that you have to remember for the source transformations. If you get the circuit that similar like this one, you can see that you have a Vs that is in parallel with the Rx. You can neglect the Rx by removing from the circuit. The resistance has no effects on the equivalent circuit because it produces the same voltage in any resistor insert parallel with Vs. And then for the current source, if the current source is in series with the Rx as shown in here, you can neglect that Rx and then remove the Rx by short circuit. The resistor has no effects on equivalent circuit because it produces the same current in any resistor insert series with the Rs. So before you calculating or solving the circuit using source transformation, make sure that there is no Vs that in parallel with Rs, and then there is no Is that in series with the Rx.